What's the purpose of partial fractions? To split an existing fraction. Partial fractions can help us break down an integrand and make it integrable. Start with a proper rational expression. If not, do division first. Factor the denominator into linear factors, write out a partial fraction for each factor and every exponent of each, multiply the whole equation by the original denominator, solve for the coefficients by substituting zeros of the denominator. The partial fractions that we solve in Calculus BC are not quite as complex as the partial fractions that we do in pre-calculus, so once you understand the process, it's quite easy to replicate. For example 1, we have a proper rational expression. Factor the denominator into linear factors. This denominator can be factored to be x minus 3, x minus 4. The partial fraction decomposition of this would be some number over the first linear factor plus some other number over the second linear factor. Now that we've written the partial fraction decomposition, we can multiply the whole equation by the original denominator, x minus 3 times x minus 4. In order to solve for a and b, we're going to substitute in the zeros for x. To make x minus 4 equal to 0, x would have to equal 4. And we can solve for b and get 1. Then I'll substitute x equals 3 to solve for a. And we get negative 1 for a. This integral can be rewritten as the integral of two separate fractions, a, which is negative 1 over x minus 3, plus b, which is 1 over x minus 4. The integral of u prime over u is ln absolute value u. And there's our result. We'll follow the same type of process for example 2. Factor the denominator. So my partial fraction decomposition will be in the form of a over x minus 3 plus b over x plus 1. To solve for a and b, we'll multiply both sides of the equation by x minus 3x plus 1. Plug in the zeros for x plus 1 and x minus 3 in order to solve for a and b. Go ahead and split the fraction in your integrand to be in the form of your partial fraction decomposition and plug in a and b. And our result is the sum of two natural log functions. For example 3, if I used partial fractions to solve, the solution would be ln absolute value x minus 3 plus ln absolute value x plus 1 plus c. But if you notice, this integrand is u prime over u. So our solution here is ln absolute value u plus c. Is that the same answer you would get with partial fractions? Yes, because by properties of logs, we could factor this to be x minus 3, x plus 1, and the log of a product is the log of each piece of the product. The log of a product is the log of each piece of the product added. Either of these would be acceptable answers. What do you notice for example 4? The degree of the numerator is greater than the degree of the denominator. If it is greater than or equal to, you need to do long division first. After long division, this integrand is equivalent to this. I know the integral of x is x squared over 2. I know the integral of negative 1 is negative x, but I don't know off the top of my head the integral of 2x over x squared plus x minus 2. I think we're going to have to do some partial fractions. Factor the denominator. Plug in x equals 1 and x equals negative 2 to solve for a and b. This integral can now split into these two linear factors, plugging in a and b. A and b are the numerator of a fraction, so you can also take them out of the integrand and just multiply them by the fraction itself, making our final answer x squared over 2 minus x plus 4/3 ln of absolute value x plus 2 plus 2/3 ln absolute value x minus 1 plus c.